เดี๋ยวผมขออนุญาตแนะนำคุณบ๊อบบี้นิดหนึ่งนะครับก็คุณบ๊อบบี้เป็นทีมงานจากบริษัทโซดาวิชั่นที่ประเทศสิงคโปร์นะครับก็โซดาวิชั่นเองทำเป็น Exclusive นะฮะ Distributor ของ Basler ในโซนSoutheast Asia นะครับแล้วก็มีสาขาในประเทศไทยด้วยนะครับก็วันนี้จะเข้ามาแลกเปลี่ยนประสบการณ์ในเรื่องของ Machine Vision กับเรื่อง AI นะครับให้ทุกท่านได้รับฟังนะครับก็ระหว่างพรีเซนต์ถ้าผมจะแปลเป็นช่วงๆนะฮะแต่คิดว่าทุกท่านน่าจะพอเข้าใจคอนเท็กซ์ของการสนทนาเพราะว่ามันเป็นเรื่องที่เราน่าจะพอคุ้นเคยอยู่แล้วนะครับนะแต่ถ้ามีคำถามอะไรก็สอบถามได้นะครับโอเค Bobby please introduce yourselves and your company please.
Okay, good morning everyone. I'm Bobby. Thank you for inviting me and giving me this opportunity to be here today. I would like to present and then share some information about how to jumpstart and kickstart your AI machine vision journey. Okay, we will split the day into 4 sessions. First thing in the morning, we will have some introduction about our company and as well as some of the machine vision hardware selections. Then later on, after a quick break, I will explain and then share some new imaging technologies. Followed by lunch, we will have a 1-hour lunch. Then in the afternoon, we will focus into the AI vision. Okay, so today we will be presenting a software called Pekat Vision and what are the applications and use cases that can be done with the Pekat Vision. So we are also going to do a demo for all of you to have a feel of the software. Then in the late afternoon, we will give a cloud instance to you, and then you could also try it out. Okay, first we will introduce our company. So for Soda Vision, we are founded by 3 of us, myself on the left, and then Jack in the middle, and SK on the right. So we have experience for more than 10 years. Our mission is to enable vision for every industries. So we wanted to become the most trustable solutions provider for all our customers. Okay, so prior to starting up Soda, we worked in machine vision companies. Jack worked for Moritex, and then I worked for Balmer. So we have a lot of experience dealing with cameras and lenses and lighting. So Singapore head office is established in 2011, and we focus regionally for the Southeast Asia market. We represent about 30 different brands in the machine vision industry. And last year, our revenue is about $5 million. So all in all, in Southeast Asia, we have about 22 employees as of today. So these are the 4 offices. Our HQ is in Singapore. We have 2 floors in the office, about 3,003 square feet. Then we have a sales office in Malaysia. Also, we set up Thailand office back in last year when the COVID started.
The same time as the COVID, yeah.
Yes, same time as the COVID. To be honest, I haven't seen our office. I haven't physically visited our office yet. Okay, then next we have sales office in Vietnam as well. So Malaysia, Thailand, and Vietnam, Singapore is our HQ. And we have a team of engineers in Singapore to support all the customers around the region. Okay, so if we talk about why Soda, why customer choose to work with Soda, first is because we bring a lot of partners under one roof to the customers, so we can help customers choose the best components to suit their applications. Okay. So you can see from this slide we have different camera manufacturers, including area scan cameras, line scan cameras, high-speed cameras, and also we have multiple lenses brands from Japan, as well as 3D solutions from Taiwan, from Slovakia, from Europe, and from Canada. Okay, and also we are very knowledgeable in machine vision applications. So we provide vision module as a bundle to streamline our customers' process. Okay, so we ensure that all the components are working before we ship out the modules to our customers. So this really helps the customers to save costs and increase their productivity. So we also keep talking to the customers to understand what is their real requirement. We try not to just provide hardware. We really discuss with the customer what is your applications and what will be the best way to achieve your inspection objective. Okay. In this slide, we show some of the past examples that we have done. For example, connector pin inspection for the automotive industries. Then we have some point cloud images from a box. This is we use it for dimensioning for some logistic industries. Filling level inspection using SWIR cameras, short wave infrared. I will also cover about this in the later portion of the presentation. Then here we also use some OpenCV and PyPylon to do fish counting. This is also for some institute research project where they would like to study the behavior of the fish under certain situations. Apparently, they will also feel scared and stressed when there's foreign reasons that is introduced to them. Okay, so in our Singapore office, we have a vision lab. So this is where we keep all the components, hardware components. We have about 600 to 700 different lenses, cameras that we allow customers to come and test. Usually they will bring their samples and then they will drop by our office for 1 or 2 hours to capture some images. Station as well as a robot picking station where we can do some feasibility studies for automation projects. So sometimes we also provide loan items to the customers if, for example, the samples are not allowed to be taken out from the factory. Okay, these are some of the customers that we work with. Okay. For example, in Singapore, we work very closely with HP, Hewlett-Packard for the server products as well as the inkjet products. Then we also have some government-related authorities, land transport, ST Engineering. We also have some smart cities related applications as well as government-related projects. In Malaysia, we also one of our key customers is also the Dyson. They do a lot of inspection for their hair dryers, vacuum cleaners before they ship out their products. Yeah. Also want to highlight is Seagate. This is also very good partners, very good customers for us. Seagate factory in Singapore is 5 minutes walk from us. So we work very closely with the team here to develop vision solutions. Okay, so we work very hard and study very hard as well. So we try to visit different exhibitions and also learn about what is the most advanced in the machine vision field. Okay, so some of the challenges that faced by customers. We talk to customers, usually they always ask which components are actually needed for machine vision. Okay, and another thing would be who can I actually contact for the consultancy of a vision solution design. Components you can find very easily, maybe from online. You can buy cameras here, cameras there, or lenses from another supplier. But how to fit all these together in a complete product, this is some knowledge that we can share with the customers. So we have a lot of experience in this. So that's why we think we can help the customers to shorten their time to market. Okay, we are our customers. We have the cameras, lenses, LEDs, 3Ds, and AI softwares. Okay, and on top of that, we also cover a wide varieties of products. We have the mainstream product for some customers who really demand the kind of accuracy that they need. We also have the high-end product, 20 megapixel or even higher. Then sometimes we also have very niche and advanced products. Okay, these are specialty specific for certain industries. Okay, one of the vision modules that we provide to our customers, instead of just selling the cameras or the lens or the light, we sell them as a whole calibrated set. In this case, we make sure that the lens are assembled, camera and lens are assembled correctly, and then we provide a pre-delivery report. So we check the lenses, we check the image for cleanliness, we check for the right resolution, we make sure that there's no distortion or the distortion is properly controlled. We adjust it, and then we make sure that the light also meet the requirement by the customers. So we use test charts, we supply the test report with all the test charts together with the vision module. Yeah, so we promise to customers that once you get this, you can plug into your system, develop your software, and you are sure that the system will work. So you don't need to worry about changing, troubleshooting where is the problem, why this system can work, the other system cannot work. Okay, then we talk about the AI machine vision platform. So for us, basically we can separate the machine vision platform into the hardware and software side. Hardware is the same, but on the software, we have also a few options. First, we have the Pekat Vision, and second, we also have Matrox Imaging, then followed by something which is not so common in machine vision industries, but in general for the computer vision, it's very popular, which is the AWS. Okay, so due to COVID, Malaysia has developed its own app called the MySejahtera. So on the app itself, they have something like a risk status display on the app. So for some factories, they would like to develop some kind of camera systems to check every employees before they come into their factories. So we also, when the COVID situation was going worse in Malaysia, we also quickly developed such an app within 1 week. And then we share the source code in our website so that any users in Malaysia who would like to implement such a features in their factory entrances can quickly deploy, make some customized changes based on their own preference and use it in their factory.
Sorry, Bobby, this app is to check what, or just to record the timeline of the visitor?
No, this app is made by, this My Sejahtera app is by Malaysia government. So depending on the person, every person, some will have a low risk, some will get a high risk. Maybe you have, yeah. So some customers who are the factories, they want to check every employee before they come in. If you are red, you cannot come to work.
Yeah, I know, but the condition of the red or not, I mean green, is come from the timeline or the health condition?
I think both.
Okay.
So the user has to key in their information, and then the app will give them a red or a low risk or high risk.
So, yeah, in Thailand also
so
we have.
What we provide is so the factories, they want to check this screen before they are allowed to enter to the factory.
I see. Yep.
So they deploy some kind of gantry with a cameras, the automated gantry with a camera. So the operator has to show this page, take an image, check the date is right, and then if it is low risk, then they can enter. If it is high risk, they cannot enter. And then the system, some customers, they made the system to send an alarm to security or the manager. Yeah, we publish the source code for this detection in our website. Yeah, if anyone is interested, is using OpenCV. So if anyone is interested, can download it from our website. Okay, so this is another project that we worked last year. Due to the COVID testing, Singapore researchers developed a new testing systems using robotic and automations to slash the manpower cost and time. So each systems can add about 2,000 to 4,000. So in Singapore, they deploy about 16 or 60 is the testing capacity to this system. And it's very sure, I think, because only took about 3 months for such. Okay, so in this training, you will learn about the architecture of a PC-based AI machine vision system. And then I hope that's to share more about the fundamentals of various imaging hardware and software. Then there will be some selection techniques that I'm going to explain to how to choose different imaging components. Then before we go to lunch, I will also explain some of the imaging techniques that is quite new and quite interesting in the market.
Wow, okay.
Then after lunch, we will explain about the Pekat Vision and also some demo and hands-on session. Okay, so for the PC-based vision system, we can actually split into 2 parts. One is the image acquisition part, and then another part, it's the image analysis. Okay, so for the image acquisition, this consists of usually you have illumination, we call it the light, and then a lens and a camera. So all the data on the camera will be transmitted through a cable to a PC. In the PC, you then have various options of software for you to process the image. So what is the advantage and disadvantage of a PC-based machine vision? PC-based vision system is very flexible. You can customize it to fit for different applications. You can use it for simple applications, then you use a smaller PC, less powerful. Or in the case when you need a very high performance one, you could easily upgrade to a 2 PC or 3 PC solutions. Okay? System can be upgraded easily without adding or modifying system components. So PC also offers a lot of computing power and speed compared to a smart camera. But the disadvantage will be there are some minimum requirement of integration, and the difficulties varies by the person's experience and also knowledge about the PC-based systems. You need certain experience and certain knowledge to be able to shorten the implementation time. So what are the typical applications for a PC-based system? When you have multiple cameras, more than 4, then the logical choice will be go to a PC-based systems instead of a controller-based systems. When you have a very high-speed inspection and high throughput, there's a lot more options in the PC-based vision system. Then high resolution image quality. If you need certain minimum standards for the color or the sensitivity, then the PC-based systems also offer a lot more choices for you, especially in the machine vision cameras. And you have a complicated inspection tasks that you may need to add certain features. This is also a strength for the PC-based vision system. Okay, some customers or new users who never implemented a vision before, they always ask what are the available cameras and lenses, and how do I actually choose the right one for my applications? Okay, do I choose the most expensive one or the cheapest one? Is there some way to optimize to get the best performance at the lowest possible price? Yeah, so here we will try to answer your questions. Okay, the objective of selecting the best hardware is to get the best images during the image acquisition part. Okay. So resolution is determined by the sensor size and also partly caused by the optics. Then the feature contrast, this is determined by the lighting and also the quality of the optics. You have a very low contrast image but very high resolution, also no use. You have a lot of data to process, but you cannot get the objective that you want. So the two key things to get a good hardware solution is to get the sufficient resolution and to get the best feature contrast. So first thing, we look into the camera part. Cameras, there are 4 different types of cameras in the market. First is a 3D cameras, then you have area cameras, line scan cameras, and then some special cameras, for example, shortwave infrared cameras or thermal cameras. But thermal cameras we will not cover here today. We only cover 3D area, line scan, and so on. So what is important in a camera? Camera, first thing we have to look at is the sensor size. So different cameras has different sensor size, from the biggest all the way to the smallest. So 1/3 inch is common for the machine vision cameras. 2/3 also very popular recently because of the 5 megapixel resolution. Then for higher resolution, the size really goes all the way up to 35 mm or even bigger. Area scan are commonly found in many machine vision applications. There are quite a wide range of sensor size and resolution for you to choose from. And typically, a larger sensor size can accommodate more pixels. That means if you look for high resolution cameras, high chances are the sensor size is going to be bigger. Okay, why resolution is important and what is a resolution? So resolution is the number of pixels on the X and the Y axis of the sensor. So you have X axis here and then Y axis here. So this is why it is called a area scan sensor. You have X and Y. More pixels can achieve higher details. So if you imagine this image, if I separate them into only 5 by 5, 25 pixels, then each pixel is much bigger compared to a higher resolution camera. Okay. So the formula for the resolution will be resolution is the object size, the FOV, divided by the size of the details that you want to be inspected. So for example, object size could be 50 mm, and then the details that you want to check is 50 micron. So what is the resolution required? You will take 50 mm divided by 50 micron. So you get about 1000 pixels. There are some construction going in my office. Can you hear the noise or it's fine? Okay, so if everything is okay, then I will continue. For machine vision applications, more pixels is not necessarily better. We need to optimize this. Okay, the image quality, why I say the pixels, not more pixels are better, because when you increase the number of pixels, your sensor size become larger and your choices of lens is also lesser. And the pixel size for higher resolution cameras sometimes can be smaller as well. This will affect the image quality due to the smaller pixel size. Okay. So what we always advise customer is choose the lowest possible for the application. If your application can reliably detect the defect using a 5 megapixels, there's really no reason to go to 20 megapixel. Even though the price is slightly higher. But let's say in the PC, you will have a lot more data to process. So these are some of the market industry standard. So for example, like defect detection, we recommend about 2 by 2 pixels required. Then for the feature location, is 3 by 3. To differentiate the features, you need about 5 by 5. But if you are going to do a measurement, it's possible to use a sub-pixel resolution. So some algorithms can really give you like 1/10 of the desired tolerance. Okay, so for example, we have this. Imagine this is a defect. If your pixels are lesser, in this case, yes, maybe you can detect this. But if the object or the defect is in the center of 4 pixels, then there's a possibility that you will not be able to isolate this defect or detect this defect. But if your object is occupying 4 pixels, which is the minimum 2 by 2, then you will detect this as a defect. And if your defect is somewhere in the middle of 8 pixels, there's also a chance that you are going to detect this defect. So the bottom 2 options is you will have a higher probability for you to detect the defects or the features. Okay, another thing when we talk about resolution, the file format is also critical. So on the left hand side, this is what we call a raw image. That means the data is really what you get from the camera itself, what you get purely from the sensor itself. So each pixel is 0 to 255. If it is a color, then you get RGB 0 to 255. So there's no processing on the image and you are getting the raw data. But with a lot of consumer cameras, maybe webcams, IP cameras, they already applied some kind of compression or image processing on the camera itself. So, for example, they are usually with a file name JPEG, MJPEG, H.264. All these are lossy compression that will cause artifact in the image. So if you look carefully, I'm not sure whether you can see it in the Zoom.
Can see, yeah.
Can see, yeah. And you can see that it's like a lot of patches, a lot of artifacts, and you can't really capture or detect the edge.
And what the file name of the raw image is? BMP something? BMP. Okay.
Yeah, BMP. Usually it's BMP.
Oh, it means JPG is already have some filter. Okay.
Yes.
BMP is a raw image. Okay.
Yes, BMP is a raw image. Some of them, sometimes they also use a TIFF, TIFF. TIFF is also a raw image.
Okay.
Yeah. So usually, what you can estimate the file size. If it is a 2 megapixel monochrome camera, that means the file size will be 2 megabyte. If it is a 12 megapixel monochrome, you will get a 12 megabyte image file. If it is a color file, 2 megapixel camera color will give you a 6 megabyte file because it's 3 RGB.
3 RGB, yeah.
If you get a 2 megapixel resolution image, but the file size is 200 KB, then you can be sure that this is a JPEG file.
Okay. No, I never heard H.264. Yeah, this never heard before.
H.264 is mainly for the IP cameras.
Oh, okay.
IP cameras. Okay, next thing that we can consider is the global shutter mode. So global shutter and the rolling shutter. On the left, the global shutter, as you can see, the sensor will capture all at once. All the pixels on the same sensor will capture the image at once, simultaneously. Then on the rolling shutter, the sensor will capture line by line. So starting from the top and slowly move across the screen, move across to the bottom. So it's saving the image line by line. Okay. Then distortion can occur when the object moves during the exposure. So on the left,
Bobby, I have question. If the shutter and the frame rate is the same topic or different?
you mean these two shutter mode? Will
I mean,
it affect
these two shutter mode, global shutter and rolling shutter. But when I saw the spec, it show like 20 frame, the same. That 20 frame rate is same, but it different. So the image is from global shutter. Yes, is for the moving capture, right? But for rolling shutter, but they say they have the same frame rate. Which one is better or something? Is there any difference between two type of the shutter type? It depends, right?
Yeah, it depends. The frame rate depends not only on the rolling shutter and global shutter, it also depends on the interface, the bandwidth available from the camera to the PC. If let's say you are using a gigabit Ethernet, so any 5 megapixel camera will only give you 20 frames. So rolling shutter will also give you 20 frames. Global shutter can also give you 20 frames because that is the bottleneck of the cable.
Yeah, okay, you continue. Yeah.
Okay. So on the left hand side, you have the global shutter image, and then on the right, you have a rolling shutter image.
Or have some distortion, yeah?
Yes. So on the car is moving while the image is captured. So as you can see, the car has some distortion. You can look at the view. It's quite obvious when you look at the view. So the view is more like an oval shape, not a circle. But the global shutter camera, this is still a circle, still round, instead of an oval. Okay, so if your object is moving when you are capturing, then you should consider to use a global shutter sensor. If you can stop your inspection, that means your object can stop and then you capture image and then go. Rolling shutter is also okay for these kind of applications. Okay, so this depends on whether the object is moving or not moving. Any other questions about the shutter mode?
มีคำถามเกี่ยวกับชัตเตอร์ไหมครับนะอันนี้ก็ใช้เลือกประเภทของกล้องนะฮะ คราวที่แล้วผมอาจจะพูดไปนิดนึงนะแต่อันนี้เขาก็มาเสริมให้ฟังอีกทีนึงนะเห็นไหมแต่ปกติแล้ว rolling มันจะถูกกว่านิดหน่อยนะ so normally rolling shutter is cheaper than global shutter right?
Yes, normally rolling shutter is cheaper because of the architecture of the sensor is a lot more simple. On a global shutter, every pixel I need to have a readout circuits because I need to capture and then read all together. But for the rolling shutter, the complexity is less. So the sensor is also cheaper, the camera is also cheaper. And in some cases, for the really high resolution cameras, global shutter cameras can be at least 3 to 5 times more expensive than a rolling shutter camera. So for example, rolling shutter 20 megapixel, you can get it for $1,000. But a 20 megapixel global shutter camera, it will cost you maybe $4,000 to $5,000.
Wow.
Mm.
Okay, yeah.
So yeah, rolling shutter, we still a lot of customers using rolling shutter. If their object is not on a conveyor belt or they can stop the conveyor belt, then it's fine. Yeah. So it's still a lot of customers using rolling shutter. All the webcams, all the phones, your phone camera, your DSLR, they are all rolling shutter camera, rolling shutter sensor.
Or even DSLR also rolling shutter.
Yes, rolling shutter.
Oh. Okay. Yeah, you can continue.
Because if you capture image, this will make you feel very fast. So you feel this is good. You are not measuring something. So when you want to measure, then you choose a global shutter camera. Okay, next, color and monochrome. We see a lot of customers. Do you want a? We always ask them, do you want a color or mono? They like to choose color because the image looks nicer. But most of the time, monochrome images are good enough for a lot of the applications. Okay, the monochrome sensor has a higher sensitivity and it gives you a much higher contrast. So that's why if you don't need a color information, you are not checking for any colors, it's always better for you to use a monochrome camera. So for example, if you want to separate red pills and blue pills, yes, you can use a color camera, but the disadvantage in this case is color image is 3 times more data. So for 1 megapixel monochrome image is 1 megapixel, color image is 3 megapixel. You get 3 times the data.
So
you can
yes, it means need the more
powerful PC. Yes, you need a more powerful PC, and you need to save. Let's say you want to save the images for future track and trace. Then every image is a lot larger. So you can also use a color sensor. I mean, a red light with a monochrome camera. So under monochrome camera, the red will become white and then the blue will become black. So you can achieve the same objective with a monochrome camera. Okay, some monochrome applications, like you are checking measurement, you are checking some shapes, there's no color. You don't need any color information. In this case, monochrome camera will work a lot better compared to a color camera. You get much higher accuracy when you are doing measurement in monochrome. So for certain cases, there are too many different colors. You cannot use the color light with a monochrome applications. then in that case, you use a color camera. Okay, so for example, in this example, the white and orange, no, the color under monochrome will be very similar. So in this case, you cannot use a monochrome camera. You need to use a color camera. Okay, when we talk about the interface is the communication between the camera and the PC. So how do we transmit the image data from the camera to your PC? Commonly, we use a lot of USB. Let's say the webcam, you understand USB very well, but in the machine vision industries, the industrial cameras has a lot more options to choose. Each have their own advantage and disadvantage, and you can choose the best one which suit your application. So two of the most common interface is USB 3 and Gigabit Ethernet. So each have their own strength and benefit. GE is common because of the cable length. It can go up to 100 meters. So if you have a very long production line, you can actually connect to the GE cameras up to 100 meters. Okay. The disadvantage for GE interface is the data rate. So maximum is 1 gigabit per second. That means 100 megabytes per second. So when you use a 5 megapixel cameras, the maximum frame rate that you can go is to 20 frames per second. Of course, there are more higher frame rate, higher GE cameras coming out as well. There are 5 GE, 10 GE. This will come, I think, maybe in the next few years. Okay. Next is a USB. USB is very common because almost all PCs has a USB port. So it's very easy, plug and play, and the data rate is about 3 times of Gigabit Ethernet. So for 5 megapixel cameras, you can go up to 70 frames per second. That means every second you capture, the camera can return 70 frames. The disadvantage is cable length. You cannot go more than 5 meters for USB 3 cable. If you need more than 5 meters, you will use a active cable. That means fiber optics. Okay. Compared to the next two, like Camera Link and CoreExpress, USB also have a lower latency. No,
So
I mean higher latency.
What is maximum length of USB? 5 meter?
For passive cable, maximum 5 meters.
Okay, but they also have the fiber optic, right?
Yes, fiber optic, then you can go up to 20 meter or 50 meter, depending on the cable.
But we cannot do the network like the GigE, right? We have to connect directly to the camera.
And there's also hub. You can use a hub as well.
Oh, okay, good.
Yes, but whenever you use a switch, in the GE it's called a switch. In the USB it's called a hub, USB hub. But they all have the same problem. They share the bandwidth.
Oh, okay.
So if you connect 5 GE camera to a switch, it's sharing 1 GE bandwidth back to the host PC. Same for the USB. If you share 5 USB camera, then the USB bandwidth is divided by 5.
Okay, I see.
Okay, then For camera link, this is a direct communication from the frame grabber to the camera. The reason to choose camera link is really because of the speed. So there's no latency, there's one-to-one communication, one frame grabber to one camera. There's no hub in between. The disadvantage will be you need the additional frame grabber, and then the cable length is also limited up to 8 meters. But the camera link is used very commonly in the past, but now it's getting lesser and lesser. More higher speed cameras and higher resolution cameras are going into the Co-Express 2.0 communication interface. Okay. So it's something similar to camera link. It's point to point, one frame grabber to one camera. The disadvantage, like the camera link, is the cost. You need a special frame grabber, and it's a little bit more complex compared to GE and USB. So we see a lot more high resolution cameras here. Normally for global shutter, 25 megapixel and above, they most of the time they go with the Co-Express interface. Okay, so how to choose? It really depends on the frame rate that you need, what is the bandwidth that you need, and then the cable length and latency. So these three criteria will decide which interface that you should choose for your application. In Southeast Asia, most of the time, GE and USB is the most common use. Okay, this is also one common question that is asked by some customers. Whenever they come from, especially if the customers are new to machine vision, when they come from consumer products background, so they have been using webcams to do their proof of concept. Okay, so all the Python programming, it's using the UVC class, okay? USB video class format. This is designed for streaming, and all the USB webcams are usually UVC compliant. So in the OpenCV in Python, there's a lot of sample codes that is written based on UVC class. It's plug and play, so you can plug in a webcam and the software just works. But in the machine vision cameras, we usually use the USB 3 vision. This is a machine vision standard designed for industrial applications. So we focus on the performance of the camera, reliability of the signal, and then device control. That means we cater a lot of consideration to control the camera's parameters. You can actually change the parameters easily using USB 3 vision. Okay, then for the Raspberry Pi camera, this is V4L2 using Linux driver framework. This framework is also very popular in the open source developer when they use a Raspberry Pi camera. So we talk about industrial cameras. What is the difference between them? Why would you choose a webcam and then or a machine vision cameras? We work with a lot of such customers, such developers. In the past few years, many companies start to look into vision, computer vision, especially AI. But when they start, they always use a webcam because that is the most accessible. They use a webcam, they use a Raspberry Pi. That is the most easily found cameras for them to try. They can do proof of concept, maybe the first system. Once the concept is working, then they start to look for more reliable options. So these are some of the things that differentiate machine vision cameras and webcam. We have customers, first they try out with a webcam, but they found that, oh, my view is not enough. I need to cover a longer distance. I need to cover a larger area. They need interchangeable lens. Then you can come to look for machine vision cameras. Okay. Machine vision cameras is usually not compatible with USB 2, so you need to customize some changes to your software. Frame rate. Normally webcam is fixed, you cannot change the frame rate. But for machine vision cameras, we have a lot of options for you to choose. 20 frames up to 100 frames, or in some cases we can go up to 500 frames per second. When you want to do multiple camera synchronizations, so for example 360 camera, you can use a 360, you can put 6 webcam, but you cannot really make the images to be the same because each camera triggers at a different time. So for a machine vision cameras, you can use a hardware signal I/O cable to trigger capturing simultaneously for all 6 cameras. So you can be sure that, okay, this image is captured all at the same instance. I/O lines, this is also not present in a webcam. For example, you want to trigger a flashlight. So machine vision camera give you the options to have an output. The cameras will tell the light to turn on when the camera is ready to capture. Fine adjustment of exposure and gain control. So machine vision cameras can give you exposure adjustment as fine as up to 1 microsecond. So for very high-speed applications, we can actually make the cameras capture at a very deterministic time. So imagine you have a conveyor belt running at very high speed, bottles. You have to make sure that the camera always capture at the same location, same time. So this is called a deterministic response from the camera. Adjustable resolution. Machine vision cameras, you can do ROI easily. You move the resolution according to your object. Okay. Next, you have the compression. So for machine vision cameras, it gives you the raw output. There's no compression on board. But for the webcams, it's always a JPEG or a H.264 data. Configuration user sets. This is also one advantage. After you configure all the exposure time and settings, you need to save the configuration to the camera so that the next time you power off and then you power on again, the settings are always the same. So machine vision cameras have the options for you to write these configuration sets to the camera itself. So you don't need to do it in your software every time you start. Is there any questions about this?
Yeah, I think no question, Bobby. Yeah, it's very clear. Yeah.
Okay, I think there's also one frame rate. We always get questions about the frame rate. The speed of motion is not really related to the frame rate. You can use a very low frame rate camera even with a high moving speed application.
Really?
Yes, frame rate is a throughput. I need to capture 100 images per second. Yeah, so this is a throughput. That means I want to sample 100 samples per second. But it doesn't mean that my object has to how to say, your object can move very fast, but I don't have 100 objects in 1 second.
Yeah, impossible.
Yeah.
But so it doesn't mean that we have to select the high frame rate camera to capture the high speed moving part. So we
Correct.
We just select the global shutter. That is the key.
You need to select the global shutter, and you need to make sure the exposure time is very short.
Okay. อันนี้กำลังคุยกันเรื่องว่าไอ้กล้องที่มีเฟรมเรทสูงๆนะครับมันเขาบอกมันไม่ใช่เป็นคำตอบของการตรวจสอบชิ้นงานที่วิ่งเร็วๆนะครับเพราะว่าชิ้นงานที่ปกติเฟรมเรทกล้องก็จะบอกกันเป็น30เฟรมต่อวินาที60เฟรมต่อวินาที100เฟรมต่อวินาทีซึ่งในความเป็นจริงแล้วมันไม่มีอะไรการเคลื่อนที่อะไรที่เร็วขนาดนั้นในโลกความเป็นจริงนะเพราะฉะนั้นสิ่งที่จะบอกคือว่าก็ต้องเลือก global shutter ก่อนนะฮะเสร็จแล้วก็ดูว่ากล้องตัวนั้นเนี่ยมัน exposure time มันสั้นแค่ไหนนะสำคัญที่สุดคือ exposure time โอเคบ๊อบบี้ next
Okay, next. Okay, next we will talk about the lenses. So lenses, there are actually a few kinds. The most common one is the CCTV lens or the fixed focal length. Okay, this is the most common one. Then we have telecentric lenses, line scan lenses, and objective lens.
Wow, what is objective lens? Yeah.
Okay, let me see whether I have. Okay, the objective lens is for high magnification, very high magnification. So you want to see objects maybe in 1 mm by 1 mm FOV. Then we will use the objective lens. 5x magnification, 10x magnification, or 50x magnification.
Okay, yeah, you continue.
Okay, so fixed focal length is the most common use lens in the industrial applications, and they cover a wide range of FOV and working distance. So there's a focus ring at the bottom. That means you can really vary your working distance and then focus. Far distant objects appear smaller and closer objects appears larger. So normally you will hear, for example, 5mm, 8mm, 12, 16, 25, 35, 50, and 75 mm focal length. Okay, these are the common choices that you have. Next is the sensor size. So the lens must be able to support the sensor size. So when you look at the data sheet, usually they will say 2/3 inch, 1.1 inch, or some is half inch. Then we have a iris. This is f2.8. That means the aperture maximum is f2.8. Mounting, C-mount. So you have to take note. If you are using a C-mount camera, then you choose a C-mount lens. Some cameras, like a high-resolution cameras, are using a f-mount. Then you will need to look for a f-mount lens. MOD, this represents the minimum operating distance, minimum object distance. So 100 mm MOD means your lens to object must be more than 100 mm, or else it will not be able to focus. Okay, lens mount. So this is the interface between the camera body and the lens. So you have a camera here, and then you have a lens here. The interfacing part is called the C-mount. So this is most widely available for the machine vision cameras, up to a sensor diagonal of 20 mm. Then you have some smaller one. This is called the S-mount. So what is a focal length? The focal length is defined as the distance in mm from the optical center to the focal point. Okay, so this is the focal length. The focal length of a lens will affect the angle of view. So if you use a higher focal length like a 50 mm, what you see is a very small area. Your FOV is small. But if you use a wide angle lens like f8, focal length 8 mm, then your field of view is bigger. Okay, shorter focal length, you get wider angle of view. So for example, 8 mm, this is the view. 25 mm, you are seeing a smaller area, but a bigger object. 50 mm, the object is even bigger. So the object also looks closer to you. Okay, the term image circles describe the surface of the sensor that is irradiated by the transmitted lights without any shading on the edge. So this is called vignetting. So normally when you choose a camera, they will tell you this is my sensor size, 2/3 inch, and you need to find a suitable lens with a 2/3 inch matching. Okay. So the image will show the same without any dark corners. But if in another case you choose a smaller sensor size for the lens, what you see is something like this. You get a dark corners on the four corners. So this is what we call a vignetting. So smaller format lens cannot be used on a larger sensor because it will have a vignette issue. But you can use a large format lens on a smaller sensor. Yeah, so imagine this circle is the lens, the rectangle is the sensor. If the circle is smaller than the sensor, then you get the black corners on the image. In the cameras, we talk about resolution, but actually for lenses, they also have a resolution. In the optics, we call it the line pair. Let's say if the two lines are too close together, in the sensor, it looks to me is the same. I cannot differentiate the white and black line. So this is what we call not resolved. I can't differentiate the 2 points. So when the line is further away, I can differentiate. Then this is the line pair represented by the lens. It's like a resolving limit. So the resolution of the lens must match with the pixel size of the sensor. You can have a very small pixels sensor size, but if my lens cannot resolve it, then there's really no advantage of using these kind of sensors. So there's the same object on after I use a high resolution sensor, maybe I will get 10 pixels on the sensor. It doesn't mean that I can differentiate 2 pixels. Okay, so optics is equally important, okay, not just the megapixels of the camera. Okay, now we can go through a simple example on how to choose a suitable camera and lens. So let's say we want to detect a defect of your product. Then the requirements are as follows. Let's say your smallest defect is 200 micron, and then your object size is 240 by 200 mm. The third criteria, the object is moving during inspection. And then due to mechanical constraint, my working distance cannot be more than 400 mm. Okay, so optical resolution, like we mentioned earlier, usually we use 2x2 to define a defect. So my defect size divided by 2 is 100 micron. Based on the inspection area given, I will take 240 divided by 100 micron to get 2400 pixels. So the resolution of the camera that I need is 2400 on the horizontal side and then 2000 on the vertical side. Okay, next, based on criteria number 3, the object is on the fly, moving, so we need the shutter speed and we need the global shutter. Okay, then we can choose, like for 5 megapixel, the resolution is 2004 by 2000, so the resolution is okay. Then we need to choose a global shutter camera. For defect inspection, most of the time we try to use the mono camera. Like I said, mono camera give you a better resolution, as well as a better contrast for the defect. Then next, for the interface, it depends on the frame rate and the cable length that you can use. You could choose a USB or you could choose a GE cable. Okay, how to choose a lens? So we can use usually the lens provider have some kind of calculator. One of the options is a Basler lens calculator, so you can actually key in, select the camera that you want to use, fill in the FOV 240 by 200, then you fill in the working distance. Then the calculator will give you a recommended focal length 13.6, but there's actually no lens in a 13.6 focal length, so you will choose a 12 mm or a 16 mm. But if you have a maximum working distance of 400, if you choose a 16 mm, the working distance will go higher. So the next nearest option will be 12 mm. So you need to choose a 12mm lens. The max image circle is 2/3 inch because the sensor is 2/3 inch. Any questions for the lens?
Bobby, you have this copy of slide to share the attendance?
Can later after the presentation, I will send you
Okay.
the PDF.
Yeah. Okay.
Okay. Okay, next we talk about the illumination. So the objective of the illumination is to create a good contrast between the object's features and the background. So like the examples on the bottom, we want the features to be as clear as possible, okay? Separated from the background. So you see the top images, I see the background, but I cannot see the features. So the purpose of illumination is to create this kind of contrast. There are many ways to do it. Like the types of illumination, we have a different bar light, ring light, backlight, dome light, coaxial light, and spotlight. This will depend on the shape of your object and also the lighting angle, how to use. So on the left hand side, we have a bar light, and then we illuminate the object from the top. Then for the right hand side, we have some kind of a ring light to illuminate. So if you move the ring light up and down, the lighting angle change as well. You have a dome light. Then on the left, bottom left, this is a coaxial light. So the light comes perpendicular to the object. So it comes from the side. There's a half mirror, and then it will go down to the object and go back up to the camera. And then lastly, we have the backlight. So backlight, what you see, you can see this is a black image. That means the background will be white color and your object will be black. So for macro, there's also one option, which is to use a coaxial spotlight. So it goes through the lens and then go back up. The advantage is this is sometimes very convenient and compact compared to this kind of coaxial light. Okay, techniques are usually categorized by the angle or the direction of the illumination source. Okay, so we can usually, when we do testing, we play with the angle. We choose a light and then we shine on the object and then try to find the best angle that gives the best contrast. Okay, for example, PCB inspection, using a diffuse illumination, we can see, let's say if my objective is to look at the characters on the IC, then a diffuse light will be a better choice compared to a direct front light. Okay, it is useful to check for specular or polish and shiny metallic object. So there's also a bright field versus dark field. So when we talk about bright field, is I want the features of interest to come back to the camera. So usually the light will be high angle, go down and then go back up to the camera. For dark field, it's usually low angle light. This is for flat polished surface. So let's say this is a flat one. If I use a low angle light, it will reflect and then go outside the camera, go out of the camera, so your image will appear dark color. But if there's a defect or dent or emboss, the low angle light will reflect back to the camera. So in a dark field applications, the defect will become white color and the background will be black color. This is what we call a dark field illumination. So for the bright field, the background will appear white color, but the defect will appear as black color. So in this illustration, the blue color represents the bright field, and then the red color represents the dark field. Any questions about the bright field and dark field? Please stop me if you have any questions.
มีคำถามไหมครับอันนี้นะฮะ
Yeah, so this is two examples of bright field and dark field. So bright field, the background comes back to the camera. So I see something in the background. The object of interest, the feature of interest is black. Okay, you look at this blue line. The background goes back to the camera. So I see white color. And the features are reflected away from the camera, so I see black dots. For the dark field, it's the opposite. So the background is black and the features are white color. Okay, so for measurement, sometimes we use a backlight to create a good contrast between the object and your background. So we can get a very good contrast between the object and the background to do some image analysis. Okay, next we have a colors concept. So we can actually use the color to lighten the image or use the opposite color to darken the image. So for example, red and green are opposite. So for example, by using some colors, we can actually eliminate the background and only make the black color appear. So in this case, we use a blue light. Okay, that means the background of all these patterns are actually printed in blue. So when we use a blue light, the background will disappear. Okay, so that's all for the first part. Shall we take a break here?
Okay, yeah, we can take a break around 10 minutes, yeah. And
okay.
We come back at 10:45.
Okay, can, yeah.
Okay.
Any questions can actually ask me anytime.
โอเคก็เดี๋ยวเบรกกัน10นาทีนะครับเดี๋ยวกลับมา10:45นะฮะระหว่างนี้ใครมีคำถามอะไรก็คุยได้นะครับผมก็อยู่ตรงนี้ฮะก็ใครจะถามจะแชทมาถามหรือว่าจะเปิดไมค์สอบถามเลยก็ได้นะครับก็ถือเป็นการท็อปิกหลายท็อปิกเราก็ได้มีการแชร์กันแล้วเนาะแต่ก็ คุณบ๊อบบี้ก็มานำเสนอในมุมมองอีกที่แตกต่างก็เห็นภาพที่ละเอียดมากขึ้นนะครับนะฮะโอเคครับเดี๋ยวกลับมานะครับเพราะว่าทางคุณบ๊อบบี้เขาพูดช้าๆนะครับ แล้วก็เนื้อหามันก็เป็นเนื้อหาที่ผมเคยบางส่วนก็เคยพูดคุยกันแล้วเนาะก็ถือว่าเป็นการทบทวนนะแล้วก็มีเคสมีตัวอย่างรูปใหม่ๆให้ดูนะครับโอเค Bobby you can continue you didn't open microphone
Hello,
yeah I hear you
okay. Okay, next I would like to cover some new imaging technologies. Okay, 3D. Sometimes image processing is 3D is difficult. Okay, so for example, in this example, can you spot the missing cookie? I mean, which one is missing and missing by how many?
Don't know.
Don't know. You can't know. Okay, it looks all the same from the top. But using a 3D information, a depth map, you can actually identify that all. So first one, cannot see the mouse. So the second and the fourth is the full, and then the first and three is lesser. So another example. So this customer would like to find all the holes of the breaker and use a robot to seal the hole with some sealant. To get the position to identify the hole in this kind of 2D image is not easy. There's too many wires, too many different circles, patterns on top to actually to be able to correctly identify what are the holes, where are the holes. So instead of using a 2D image, we can use a 3D with a depth map. So by running the depth map, we can isolate all the circles on the breaker and then accurately give the XY position data to the robot for the sealing. Okay. So depth map can be generated from the 3D scanner, and it's not affected by the environment lighting condition. So 3D scanner can have their own structured light. It could be a laser, it could be a pattern projector, and your image algorithm will not be affected by the printing label and other wires on all the components in the electrical panel. So next example, let's say the customer would like to check whether there's a foreign material inside the pallet and whether the pallet is there any defects, broken. So using 2D camera, yes, this is a foreign object. You could use a blob analysis to identify. But if you use a blob 2D image analysis, is the shoes behind the pallet also considered as a foreign object? So, but if you use the 3D camera, 3D depth map, we can actually differentiate. You see, this is a real foreign object under the palette, but the shoes is not a foreign object under the palette. And also at the same time, you can actually see that the palette, this is a defect, and then here there's also some missing defect for the palette. There are many different 3D technologies in the market. So here I show some examples. We have stereo imaging. So stereo imaging can be considered as one of a passive method. That means it is based on whatever light that you have. So it can be used in the sunlight, it can be used outdoor, it can be used indoor.
So is there any minimum lightings that this kind of the 3D require?
For stereo?
Yeah, for stereo, yeah. Or same as our eye. If our eye can see, this one can see also.
The weakness of stereo will be you need a certain, because it's capturing two images, and then the software will try to match the two patterns together to find the distance. So it needs a certain pattern on the image. If your image is very, very flat, let's say a white wall, there's no features for the software to compare.
No pattern, yeah.
Yeah, no pattern to compare. Then you will have a problem. You will not get a good image. Another possibility is you have too many of the same pattern in the scene, in the image, so it may match wrongly. Then you also get the garbage output from the stereo camera.
Okay. Yeah.
So in industrial application, although you can use a stereo camera without any light source, but normally it's always recommended to use a structure light, some kind of a pattern projector, random pattern projector. So it will project laser patterns on top of your sample, and then the two cameras can look at the sample, look at the patterns, and make the disparity calculation to get the depth map. Okay. Then we have the laser-based triangulation. So this depends on moving. There's a laser, and the laser will calculate the height of the object, and you have to move the sample in one direction to scan the sample. Next will be structure light or pattern projector. So it will project a certain sequence of pattern on top of the sample, and based on the return image, the camera can actually calculate what is the height of the object. So the pattern are usually like a phase shifting pattern, so they changes in the pitch, and based on different pitches, they can calculate what is the depth of the object. So for structured light, the object cannot move. It has to be stationary for a certain period of time. So for example, if the camera is taking images of 17 different patterns, then the object has to stay there for that period of time. It cannot move. Then there's also some TOF camera. This is a time of flight camera. For time of flight camera, the advantage is your object can move, and it can cover a very long distance up to 30 meters, but the limitations will be the resolution. is only up to 5 mm accuracy in terms of Z distance, 5 mm, and the resolution XY is about 640 by 480. Okay, then there's Intel RealSense. This is also very common in the market. We have this LEAPS, which is Intel RealSense in a gigabit Ethernet interface. So you can use it with longer cable distance and also multiple through a switch. Then we have the LiDAR sensor. This is to scan a large distance, large FOV, and a long distance. Okay, next we would like to share about the infrared imaging. So infrared, we have two categories. One is the near infrared, that means from 750 to 1050 nanometer. Shortwave infrared is from 1050 to 1550 nanometers. So for visible wavelength is usually 400 to 750 nanometers. So where can we use SWIR imaging? Okay. So for surveillance, for security and safety, SWIR can penetrate through haze and smoke. So for example, border securities, they use SWIR cameras to look at the sea for vessels monitoring. Then next, for SWIR cameras, we can also do certain kind of temperature checking. So like for example, under a normal, this is a soldering iron at 400 degrees Celsius. In a normal cameras, it looks like this. But if you use a SWIR camera setup, you can actually see the tip becomes white color. But the temperature has to be more than 200 degrees Celsius. Then only you can see this kind of response from the SWIR camera. Another applications is food inspection. So color images is used to grade the fruits. You can sort them by color, but at the same time, some applications is also using SWIR camera to identify defect on the fruits. Water is able to absorb the SWIR wavelength, so that's why if you have you want to detect certain leakage, you can use a SWIR, because after the liquid absorb the SWIR, it will become black, so you can actually see a black dot when there's a leakage of liquid. So under normal light, the liquid is transparent, so you can see it. And SWIR will also help to remove all the printing from the image. So this is a characteristics of a infrared wavelength. Next, for packaging products, we can also check for the inside of a packaging whether there's a product or the product has some kind of defect. For example, instant noodle is also possible. We can use it to check the presence and absence of powder inside the instant noodle. Fill level, as I mentioned earlier, the water will absorb the swirl wavelength, so it will appear black under the swirl image. So from here you can actually detect the filling level as well as the leakage. Same for pills. If you like to differentiate whether the pills have some kind of moisture, under swirl light it will also become black color, darker. Composite material detection. So different acetone ink and IPA also contains a different level of H2O. So by checking the intensity, you can actually differentiate them based on the intensity. And of course, one thing to take note is different material reacts differently under wavelength 1050 or 1300 or 1500. So in this example, to check for IPA and H2O, 1300 wavelength is the best option. Then for these two, you will need to use the color camera to check. So under swirl, both are the same. Okay, same case for the fruit inspection. So using bandpass filters, we can actually isolate the wavelength and then make some comparison between the products and to find the suitable wavelength for the application. Okay, next is a high dynamic range imaging. So what we could do sometimes when we have a complex product that have a varying reflectance, let's say if the character is very reflective, so if I use some light that I can see the background but I cannot see the text, so in that case we have to capture images from the same object but 3 different exposure time, 3 different lighting setup. Okay, one to see the character, and then second one to see some background, and then the third one I need to see the darker objects, so we can have a exposure difference in between the images. And next we combine all the 3 images into one image. So this one we can is possible to do it with software, and in the industrial cameras this is an advantage as well, because in the industrial camera you can actually set the exposure time as a sequencer mode. So you program the exposure time required in the camera memory, and every trigger it will capture the images sequentially. So first image you capture exposure time 100, second image you capture exposure time 500, third image you capture exposure time 1000, and these images will then be sent to the PC for processing.
This filter is in camera, right?
Sorry?
This filter is inside the camera or is it type of the camera?
The camera can help you with The camera can help you with the camera settings, the exposure time settings. So it will capture 3 different images, but to join the 3 images together, this one still requires a PC. It will be done in the PC or a FPGA. We managed to do it in an FPGA. So for example, if you use a frame grabber, we can capture the images and then combine them in an FPGA before sending to the processing software to process.
Okay.
It's very commonly used also in the traffic application, car plate number identification. So certain like cars, you have black cars and you have white cars. If I fix the exposure time based on white car, it may overexpose or underexpose. So they always capture multiple shots and find the best shots. Okay, next is focus stacking. EDOF actually represent extended DOF. So when we capture something very small, as you can imagine, the depth of field is usually very shallow as well. So only a limited amount of focus can be captured in every images. So it's like a semiconductor when we do capturing at 10x magnification. As you can imagine, the DOF is only maybe 0.5 mm. So in order to inspect parts, we have to move the lens up and capture 20 images or 50 images. So with software and FPGA processing, we could vary the focus and join them together. So this is called the focus stacking. So in this example, 20 images were taken with 20 depth of field, with different depth of field. So image 1, the focusing is here. Image 2, focus slightly further away. Third image, and the last image is we can focus at the background. So by using a FPGA with the software, we find the best focus for every section and then join them together to become one image. So this is also where the high frame rate cameras are useful for. So in one of our customers, they actually capture about 150 images per second, then join all these images together. Okay, so this is actually a collaboration between Buster and AWS. So they collaborate to come out with, basically they work together. Buster as a hardware provider, I'm very good at making cameras. And for AWS, they are very good at the cloud AI. So what they do, Buster come up with a standard set of hardware where you could make use of the Amazon SageMaker machine learning model that you have created. So you upload the images here, and then you train the images, you develop the ML model, and then you use this to push the model to the hardware. So the hardware will do the image capturing and image processing for inference, image inference here on the hardware level. But AWS will do the training.
Okay. So it means the hardware that the Bustler work with the AWS is that that hardware can run the AI module, right? AI model.
Yes. Can.
Oh, so do you have some picture of that?
Not yet.
Not yet.
It's still under development.
Okay. Oh, but I saw they advertise a lot already. Yeah.
Yes, they announce it, they launch it, but due to some component shortage, the actual camera we actually haven't got it.
Oh. And you know what the CPU inside of that camera? Is that JSON or?
The standard one is Jetson. Yes.
โอเคครับอันนี้ก็เป็นโมดูลที่บัสเลอร์ก็คือจากคนที่ผลิตกล้องธรรมดาก็ขยับเป็นคนที่ทำพวกembedded CPU ด้วยนะฮะก็คือมีกล้องรวมกับตัว CPU ในตัวนะฮะซึ่งก็เป็นเทรนด์ใหม่ของคนที่ผลิตกล้องช่วงนี้นะฮะก็คือพยายามที่จะเอาโมดูลที่รัน AI ใส่ไว้ในกล้องเลยนะครับเสร็จแล้วเขาก็จะผูกอยู่กับทางคนที่ให้บริการด้าน AI ก็อันนี้เขาก็ไปผูกอยู่กับของ Amazon Web Service นะซึ่งอันนี้ก็ผมไม่ค่อยมีข้อมูลเหมือนกันนะว่าเขาให้บริการมีแพลตฟอร์มอะไรบ้างนะครับนะแต่คิดว่าก็น่าจะคล้ายๆกับพวกของ Microsoft นะครับที่มีของ Microsoft อะไรครับไม่แน่ใจมีท่านไหนใช้ Microsoft Azure หรือ Azure ประมาณนั้นนะครับน่าจะคล้ายๆกันนะครับ Okay, Bobby, you have something to add about the Basler AI module?
Wait, let me look for.
Oh, this one. Wow.
This is something like a developer kit. So it comes with a Jetson board and then adapter cable to a Basler camera.
It looks like a board camera. It's not industrial shape. It's a board camera, right?
Yes.
Oh.
It's a board. So for this, usually they are looking. This is like a developer board. So it's there's a lot more things to do to make it into a product.
Yeah, our attendant is many programmer they can handle. You can introduce. So beside for this board, they can run any model. It's not just only from Amazon Web Service, right?
Yes.
Like from TensorFlow or any brand of the AI.
Yes. You can. Actually, you can. It's just a board lah. The hardware is hardware.
Okay.
Of course, when you get this AI solution kit from Basler, they will include the image that you can work easily with a Basler camera and AWS. But if you don't want to use it, you cannot, of course, use your own. It's just a Linux software on the board. They provide you the image, a ready to use image. Yes. Yeah.
And when this board is ready, it's not ready yet, right? This one. Not
This
available yet. Yeah.
The hardware available, yes. The hardware is available, but the image that is working with AWS, that is still under a lot of changes and development.
So it means we can buy this board if we want.
Yes.
Okay. ครับก็ ถ้าใครกำลังมองหาตัว developer kit นะครับเพื่อทำเรื่อง AI นะฮะก็ของ Buzler นี้ก็มีให้บริการนะฮะก็คือมีทั้งตัวที่เป็นแจ็คสันนาโนมาให้เลยนะแล้วก็มีกล้องมาด้วยนะฮะก็คิดว่าน่าจะถ้าใครใช้จะเอาไป develop กับ Sierra Core อะไรก็น่าจะได้เพราะเป็นแจ็คสันเหมือนกันนะครับโอเค you show this one โอเค
Can you see? This is
yeah I see
yeah. So we have the same hardware in our office, a JSON board, connect to a camera, and then we do this identification.